This video is by Mark Kingston from the ARA Institute of Canterbury in Christchurch, New Zealand. Okay, so this video here is works around the concept of the common central sphere. On the platform at the moment, there's 3 cylinders. I haven't put dimensions on them, doesn't really matter. Oh, sorry, they're actually 37.5 for a radius, so they're 75 millimeters diameter. So each cylinder is 75 millimeters diameter. And I've come up from the bottom, and on this line here, I've picked the center point, given a height, and then I've drawn a circle, which is the common sphere for all 3 of them. So that circle there that I've just highlighted is 75 millimeters diameter, and you can see that from the vertical, this one's going in here at an angle of 105 degrees, the other side is 135. So they pivot from this point. The circle is drawn there, and the cylinders actually, these lines run down tangent to the circle. I'll show you how to do that. So there's one with 3 cylinders coming into the center. This one has got 2 cylinders, left hand side over here, the bottom one, and then we have a cone at the top. So this one here, this common central sphere, is 75 millimeters diameter, and it's going down to a cone at 50 millimeters at the top, and it's a right cone. And you can see that this joint line, if the 3 faces were exactly the same, this would be a vertical line, but it's not. And you can also, that's slightly dictated by the center line going out through there. The next one, I've got a cylinder with a cone coming in at an acute angle, so it's a right cone again. So that's another one that you could be doing or could do. We've got an offset here. I've got a cylinder coming in from the bottom and a cylinder coming in from the top, and the center lines are offset, and the vertical height, you're given a vertical height. So what I've done is I've drawn the sphere exactly the same size as the base what would be a diameter, because it's a circle, and this sphere here is actually the same diameter as the base length, so that's a circle as well. So it's going from, well, let's actually see what that one is, linear. It's going from 36 millimeters, oh sorry, it's going to 60, I've got a radius there of 30, not looking at what I'm doing. So it's going from 36 millimeters down to 60, using the common central sphere. So it's about determining the joint line. We use the sphere to get the joint lines. And the next one I've got, okay, so I've done basically that same sort of thing with an offset. So to determine the joint line, I've drawn the spheres, and where the lines come down and hit the circles, or hit this common central sphere, that's where we actually get our intersection points for our joint line. So we can't make any pattern for a right cone or a cylinder on the end until we know what the joint line is. So that's what the common central sphere allows us to do. So you can see that I've developed out the patterns for the cylinders across the end here. I've got videos, a couple of videos up that actually show you how to do that. So I'm not going to develop the cylinders. You can see what I've done there, and you can go and look at the other videos on how to develop a cylinder. So all I'm going to do is develop a cone, one portion of a cone, and I'm going to do it on this one here. So I'm going to redraw this just so you can see how it gets done. So what I'm going to do is I'm going to draw it right beside it and show you the development of the cone. So what I'll do is which cone will I develop? I'll develop this cone on this side here. So that's the cone that I'm going to develop. So the very first thing we have to do is draw it up so we can determine our joint lines. There's 2 on the base and the joint line on the top, and from that point we can then go and develop our pattern. So it'll take a wee bit of time to do this drawing, but you need to see how it gets done to understand the concept. So first thing we'll start off with our baseline, 400 millimeters. And we've got a vertical line going up from the center point, up from there, and it goes up 300 millimeters. So the very first thing I can do is actually draw a circle at that point. And what is it? It's 400. I was going to write 200. There we go. So there's our circle for the base. And what else do I need to do here? So we're offsetting from the base up 650. So offset 650, put that line in up there, and I'm going to extend that out. We'll go out another 350 on that side, and we'll go out 350 on the other side. And what will I do? Well, I'll extend the centre line to the top, so that needs to be a centre line up there. And we've got this joint dimension over here of 559.4742. So when I drew it, I changed the scale slightly. That's why I've got an odd number there. Shunt this back to a standard calculator and scale it down. So we've got 559.4742 divided by 2 equals, so we're going to offset 279.7371. So offset 279.7371, and that is going to be the centre line of each one. So I'll just dimension that to make sure I've got it right across the top there, and it's telling us down on the bottom corner here it's 559.74, so that will be correct. So on this side we've got 170, and on the other side we've got 100. So offset 100, shunt that out to there, offset the other side of 170, that goes out to there. Those 4 lines are the ends of the straights, so we want those there. Oh, what else have I got? Okay, I've got a pencil here, I haven't written that down. Okay, so we're going to do a centre line length, an offset of 133.5314. That's coming down there, and on the other side we've got an offset of 87.0213, and that's the length of that one on that side. So what I'm going to do is I'm going to get 100 mil, so I'm going to offset 50 mil. So that's my, do it again, offset. That's my centre line for the cylinder on the right hand side, and this was 170, so offset of 85, and that's my centre line on this side. So we have a circle on the end here at 85 millimeters, and on this side we have a circle here of 50 millimeters. So those 2 circles there are going to be projection lines for the circles, and we need to tidy this up a bit. So let's get rid of some lines here. Get rid of that, get rid of that, can all go, get rid of that, and we can get rid of that. So that's out of there on that side, and this one is out of there on that side. Okay, so we've got the basic points that we need to do the development by the look of it. So the first thing I'm going to do is we run our lines tangent to the edge of the circle. Well, coming up from the cylinder it's quite easy to do. I'm just going to run the lines up to the top and stop. So that's that one, and then with these ones here we need to do a line again, but it's got to be tangent, so I have to use the tangent function there and tangent on the other end. So there's the line for that one, and then do it again for the top one, tangent, and tangent again. I missed it, wasn't looking at what I was doing. Do it again, recent input, line, tangent, and tangent again. So, and on the other side we've got tangent and tangent. You can see that it actually snaps to the position, so it's, the green is actually showing that it's actually going to be on the line, but when it snaps into the correct position where it would be. So if I put it on there, you can see it snap back to where it needs to go. So basically, we've got the information that we need on the sheet. I can clean a lot of this out again. What I'll do is I'll fillet the outside corners for a start. Do it again, fillet. So that one and that one and that one and that one. And then we're going to do a bit of a trim up on the top. Actually, we might put a joint line in. So it goes from the outside where they meet to the inside. Same on this end. Put our joint line in. So that's what we're going to be working, doing our pattern development to. More of a trim up from the line. What am I trying to do here? That one there, that one there, that one there. We'll put those in on centre lines and then trim it up here. And trim it up down the bottom here as well on both sides. So we're getting rid of that, we're getting rid of that, that one and that one. So you can see that the lines have actually stepped away from the circle, but if you run the line all the way through, it comes down and touches the circle. So we know where it's going to. Now these lines go back to the centre of the circle. And one on the other side. So there are our joint lines. That's the configuration that we're going to have. This is a cone on the right hand side. The cone on the left hand side. We've determined the joint line using the common central spheres. One large circle in the middle, which is the same as the diameter or the distance on the base. This one here is the same as the diameter on the top, and this one here is the same as the diameter on the top, even though they're straight lines. So once we've determined, actually I'll trim up my centre lines as well. Just get rid of some of the lines off the drawing. And our centre lines go from where the circle was drawn down to the centre at this end and out to the centre on that end. And those two, as I say, are centre lines, so they're going on centre lines. So we've got the information we want. Now all I'm going to do, because I've shown you in the other drawing on how to develop out the cylinders on the end, I said I'm not going to do that, and that's precisely where it's at. So I'm not going to develop the cylinder on each end at the top or the one on the base. Look at the other video and you'll understand how it works. So to prove that it's a right cone, what I'm going to do is I'm just going to draw a line up the top. So line, I'll put it down here on an angle. I don't know why am I on orthographic. I want to get off orthographic. Get rid of that one. Another line down here on an angle. So hitting the wrong buttons on the screen, like a fool, extending. So highlighting that line, bringing these lines through. So the 3 points have all met at this point here. So I can get rid of that line now and I can trim back to those points. So I'm just going to highlight all three of them and then trim them off. And that's where our cone is actually going to pivot from. So what I need to do is to determine the base of the cone. So we know where we're pivoting from at the top, and we know that this line here is the longest line down through the middle. But what I want to do is I want to redraw the base on the cone here, and it's going to be slightly bigger than this cylinder here is, which was what the original development size was. So what I need to do is draw a line, and this is just my way of setting it up. Oh, sorry, I needed to put the line in first. So we're going from that point, and we want to be perpendicular to here. And what I'm going to do is I'm going to take that line and I'm going to move it out to the very end here. So for some reason we've jumped back onto orthographic. Now what I'm going to do is I'm going to extend the cone through so I can determine the size of the right cone that I actually need to draw. So that's going through to there, that's going through to there. And then I'm going to extend this out here on this side, and I'm going to also extend this baseline. This is the baseline of our cone. I'm going to extend that through to the other side there. So there's our cone that we're going to take the pattern out of. So I'm going to trim that off. And what I want to do is I just want to show you that it's exactly the right size. So what I've had to do is I've had to dim angle. You've got to make the baseline perpendicular to the center line. So that's what I was trying to do. I'll do exactly the same on the other side. You can see both sides are exactly 90 degrees, and I'll turn the precision on slightly more, and you can see it's exactly 90 degrees. So that's what we have to do to determine the cone, the base actual size. So, and now I'm going to do a dim linear. No, I'm not. I'm going to do a dim align and show you that the two sides of the base are exactly the same length. So that's coming out there, and this side out here. So as you can see, that's 213.99, and this is 213.99. So the base size of our cone is what? If we say 214 times 2 is 428, but the actual cone that we had was 400 millimeters, because this baseline here is 400 millimeters. So this common central sphere, I think I said cone, the common central sphere, we'll do a dim RAD for rad, radius, there's your 200. This here, dim linear, is 400. 2 times 200 is the 400, but the cone size that we're going to make is slightly bigger. So that's how we're going to develop it. So I'm going to get rid of that information that I've just put on the screen, and we're going to start to develop the pattern out. So I will, so what I'll do up the top here, I will break these lines, and first point, do it again, first point, and again, oh sorry, didn't do that one the second time. Have I mucked that up? No, I haven't. Break again this line, first point. So I've just broken off the projected line. Okay, I mucked that up. I've got to go back one step. The break, first point, do it again. So I've broken those lines off. They're just the projection lines to the apex of the cone. This being the apex, where it pivots from at the very top of the cone. So now what I'm going to do is I'm going to turn off the projected cones for those bottom pieces, and so what I need to do on the end here is draw a circle for the base size of the cone. I don't want to take all day with this. Trim that off. I only need a semicircle on one side, and what I need to do is break that semicircle into 6 equal segments. Some of you will be familiar with this. So I've got to extend the center line through and circle. Now when you do this with a compass, you can often just put a very small mark either side of the line. I could use the arc function on the computer, but excuse me, I'm not a great fan of that. So what I'm going to do is, to get rid of some of these lines, I'm just going to put a little wee circle there, highlighting where the points are. Again and again, and I'm going to trim them out. Just bear with me, be patient. All will be revealed. Just getting rid of these large circles so they're not in the way. Now what I have to do, and I'm going to get rid of those circles there. How many minutes are we up to? 22 minutes. So lines have to project back to the base, so I'm going from that point there, and I need to be perpendicular on the base. So do that with each one. Perpendicular. Perpendicular. And last one. You can see that see the green square just above my line there. That's actually where it will snap to. So all those lines run right back to the apex now. So I've got my links. Now when we develop a right cone, we have to project the lines to the outside edge. So this line coming down here, what am I going to do? Am I going to do that? Yeah, I'll do that. I'll leave that. This point here where this line meets, this blue spot right here within, or the now turned to pink, that is a true length because it's on the outside of the cone. This point here that's turned to pink is also a true length, as is the top one. That's a true length. And this one on this side is actually, that's turned to pink, can also be swung as a true length. So what I'll do is I really need to number these so sizes that we want, and this is the joint line here. I might actually change the joint lines to another pretty colour so we know what we're working with. Now when we develop a cone, because this line here is a true length up to this point here, up to the green line, this line here up to the green line is a true length. We have to take these lines that are in between and actually project them to the outside edge. So that's interesting. I just thought of something. So what I'm going to do is I'm going to draw this line, and sorry, this one here, and I'm going to project it back to the center line, put it in as a perpendicular, do exactly the same with the next one, and then I'm going to project them to the outside. So this one here, 1 and 2, and then on the other side the lines are slightly different length. What am I trying to do? A line, aren't I? So that point there is correct. So this one here, if I project back to the center, it's heading in a slightly different place, as you can see, and this one coming back to the center as well, perpendicular to the center line. So those are projecting to the very outside edge because that's where they will swing from. There we go. So now we've got our circles. So in order to develop the cone, well, 3 actually, when you project that horizontally across, it becomes either 0.0 or 0.6, the center line, and that's the size of the cone that we're going to develop. So what I'm going to do is draw a circle from the apex down to 0, and I'm going to pick a line just as a starting point. I'm going to say that this is going to be the starting point for the cone. It's just a really random line. Trim that on the outside. Now what I need to do is draw all these lengths in. So we're going to this point here. Now this can get confusing. You need to, as I say, take your time to set it up properly. So that line is number 6. Actually, what am I going to do? Hang on. Sorry, I'm going to change tack. I'm going to take those lines out, and I'm going to draw in the true length of what the this rolled out cylinder inside this window here. So what I'm going to do is I'm going to take the length of that line what do we got there? We've got 427.98. I'm going to pause for a moment. So starting off again, I just had to work something out. I just realised I'd made a mistake, or not so much a mistake. Now, if I take this diameter here of this cylinder, it's telling me it's got a diameter of 12, it's got a radius of 601.69 millimeters. So I'm just working out the length around the circle with a chord length. So what I want to do is change that to scientific. So I'm dividing the baseline, or the radius. Get out of there. I'm going to divide the baseline, this radius. If I take this diameter across the bottom of the cone and divide that by 2, I'm going to take that length and divide it by the large radius of the actual development. So calculator back on the screen, and I've got 429.98, and I'm dividing that by the large radius of 601.69 equals. Now that's 0.7146 of a 360 degree circle. So I'm going to times that by 360. And that tells me that it's going to take up 257 degrees. And how many positions I'm going to go to? I'm going to go to 26337 degrees. So now that I've got that, I just need to think for a moment what I'm doing. So the large circle was 601 for a radius, 0.69, times that by 2 equals, and then I'm timesing it by sine. Oh, the calculators go back to front on this. Okay, that's really frustrating. So we'll go 257.26337 divided by 2 equals, and then push sine, and then times that by 601.69 times 2. No, it's not going to let me do it. Okay, so what I need to do again, this is going to become frustrating. I didn't want to take this much time. Divide that by 2 equals, so I got 128, just writing this on a piece of paper, 631,685, and then 601.69 times 2 equals 1203.38. Right, this time. So we're going to have 128.26337 sine times 1203.38 equals 944.86815. So this is for chord length. So I'm going to just draw a circle here, get rid of the calculator, back onto the screen, drawing a circle from this point with a radius of 944.86815, and it's going to be 257 degrees. So my line should be going from this point to this point, I believe. I'm going to check the angle on that. So dim ANG, typical. So what have we got? 103 there. So 103 degrees plus 257 gives us 360 degrees. So it's correct. So that's our cone in this zone here. So I'm going to trim out what's not required from that point to that point. I'm going to get rid of that, and I'm going to get rid of that circle. So that's our development. That's how much of a cone, or the circle, that the cone will actually take up. Now what I'm going to do is I'm going to divide this outside edge around this portion into 12 equal parts. Now you would work out the length and set it set your dividers or your compass to 12 and break this curve in here into 12 equal parts. I'm just going to use the divide function on the computer, and I'm going to hit the line, and I'm going to tell it I want 12 equal parts. So you can't see them, but there's 12 equal points there because I haven't scaled them up. So I'm going to draw lines from them. It hits the nodes as I sit over the top of them. Where are they? There's one. There's another. I can just barely see them. So just putting these in. So this is the way you develop a standard right cone. How many segments have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. That's exactly what we want. So what am I going to number it as? We'll start with joint. Okay, so where are we going to have our joint line? We'll have it down this line here, down the center line. So I'm going to draw a line from there down to there. That's going to be our joint line on line number 3. So I'm going to start off with points. I'm going to copy that point. Copy. So there's our dimensions. We're up to 36 minutes. So what I'll do is I'll do the small cone at the top for a start. So the longest length is circle down to 6, down to, oh, okay, yeah, I've still got to project those across. I haven't done it yet. So there's the outside. So what I need to do is to draw these lines. Going to get confused in a minute. Line from center line. Sorry, no, I'm not. What am I going to do? I'm going to take that line there. I'm going to project it back to the center line. I'm going to do the same on this one. Project it back to the center line. This one here is going back to the center line, perpendicular. And this point here, make sure I get the right point, back to the center line, perpendicular. And okay, so I'm going to project all those to this outside edge. So this line here, 1, 2, 3, 4. This line here I'm going to copy because I can't determine where this point here is, this pink point, which is line 3 coming down through the center. Actually, I could run a parallel, can I? Parallel. Oh, I actually haven't done that before, so I don't want to make a fool of myself. It's very easy to do that when you're doing this. I'm going to copy this line here, Control C and Control V. And I'm going to just put it on the sheet, and I'm going to pick it up, tell it to move it, grabbing it on the end and putting it on that point there. There we go. So trim those out, and so that's what the lines are going to be. So circle number 5, number 4, number 3, number 2, and number 1. So I'm going to just tidy this up a bit because I don't want to leave all this on here. I'm going to get rid of those, and I'm going to trim it out between this line and this line. It's okay. So we're going to go from, so this is line 0, this is 1, 2. So we're going from 3 down to the bottom. Okay. And I'm going to come back up to the top. Right, so I'm going to draw this in. I'm going to use a spline line. So this is 3 down to 2, down to 1, down to, if I hit that correctly, I don't know whether I hit that correctly. 3, 2, 1, that's better. 0, 1, 2, 3, 4, up to 5. Have I missed one? Might not have. Let's see, we'll just keep going. Yep, missed one. Right, so start again. That's 3, 2, 1, 0, 1, 2, 3, 4, 5. Oh, I see what I've done. Haha. 5, 4. Oh, sorry, that was 5. That's 4, and that there is 3. Now I need to lock my hand on this because if I move it, I'll be angry, and I moved it, but I got away with it. So that's our joint line for the top. So this line here was 6. It's the highest point, so it comes up at this point here. This one on the bottom here was 0, so it's down at the bottom. What I'll do is I'll turn all of these lines here into projection lines. And what else will I do? So I'm going to trim those out at this point, at this stage here, just for making this a bit easier. Yep, that's right. Right, so what I need to do is this line here is 0, so I need to swing a circle from there down to here, and so it's because it's on the 0 line. I'm going to come up here, I'm going to draw a little wee circle because I need to be really clear as to what my points are. So we'll do it 5mm diameter. So number 1 is the next line, circle down to that point there. So on the 2 1 lines, we've got a circle, and I'm actually going to do it at 10 this time. And I will scale that one up there as well. Properties, radius into 10. Highlight that, get rid of that. So next line is line number 2. Circle to line number 2. 10, 10. We know what number 3 is, so I'm not going to draw a circle for it. Number 6. This here is point number 6, so we're going to go from to number 6 at this point. This line here. So we're going to draw a circle on that. And actually I'm going to take these lines. Will I take these lines out? 1, 2, 3. Put them onto projection. Number 5, which is 5. So number 5 is going up, it's hitting that line, and that's that point there. So we're going to come down just to below there, circle, down to this one here. We'll leave it on the white in the meantime so I know which one I'm looking at. Circle, and that's 10. And same on the other side. So we'll switch that to projection lines. This line here is number 4. Pardon me. So circle again from the center down to 4. We'll leave it on white. Here's our small circle for here, 10 mil, 4 on this side. So there we go. So the 3s, because they're right at the very bottom here, if we projected this, you know, we've come perpendicular in here and we've got a 90-degree corner in here, they are right on this outside edge here. If I extend that line just through momentarily to show you, you can see that it hits dead on that point. So we'll get rid of that, trim it from there. So we know our points. So what I'm going to do is do another spline line. I'll turn this one into a projection line. So SPL, that's not it, SPL, we're going from 3 to 2, get on the screen, Mark, up to 1, to 0, to 2, oh, sorry, 1, to 2, and they're going to a sharp point, so it ends at this point here. So locking my hand onto the table so I don't shift it. That is the joint line on that side, and then on the other side we're going from 4 through to 3 to 4 to 5 to 6, back out to 5, back out to 4, and to 3. Locking my hand on the table. So there's our joint line. So we can take away our outside circle, which was a projection line around the outside, to get the, well, it's actually also line 3, but it was this baseline here, and we can start to trim off some of this excess material here. So that can go and on the other side. One. Take those out. These are projection lines. Stop talking again. These are projection lines. Projection lines. Get rid of that circle. These lines up the top here. We're going to break these lines. BR. And this line here. And our first point is right on there. And that's also the second point. So that's a projection line back to the top. And this one here. Break this line as well. First point. So that's the projection as well. So there we have our pattern for our cone. Projection lines on these ones. These are all projection lines. And what else do we need? We don't really need anything else. Get rid of these. We'll take them out just to remove some lines from the drawing. What I'm trying to do, trim. I'll just take these lines out in here. No, didn't do it properly. Actually, that's a break line as well. First point. So that's projection. baseline is also a projection for the cone. And we need to break that line as well. So first point, that's projection, text. So there we have it. We've developed our pattern. For the one that I had already drawn on the left hand side. Simply redrawn it for you to show you how to do it. Actually, it looks like what have I done? I've gone and got something slightly wrong over here, have I? What have I done with this one here? This cone here does not look exactly the same as this cone here, does it? It's pretty obvious that it's not. But anyway, let's get over the significance of that. Clearly, I've drawn it wrong. Someone will pick up on that and say, "What a twit!" What I've done is I've drawn out two cylinders coming in at the top to one cylinder at the base. The base one was 400 diameter. This one here was to be 170. This one here is 100. And it looks like I've drawn it slightly differently. But, you know, in terms of developing a cone, well, that's how you develop out the cone. This line here of the top, we had to use common central spheres to determine the joint lines, which are the green line on the top, the two green lines on the bottom. And then we had to develop our pattern using our line up through the center as the actual joint line, which is these 2 points here in development. It goes to a sharp point and back to sharp points simply because the cone goes to a sharp point down through the center here to this point. So that's why it goes to a sharp point. Most cones usually have a curve around the bottom, but that's not what we're looking at. I'll make some notes on the screen explaining where I've mucked up, and we'll go from there. But anyway, that's how you use common central spheres for three exactly the same size cylinders with slightly different angles between them. Or you could have two cylinders with a cone coming in, or you could have a cylinder with a cone coming in at a very acute angle. The offset, single offset, from one small diameter cylinder to a larger diameter cylinder. Showing you how to do the ends and then doing the development for the pattern for one side of the one that I've drawn out. So we use common central spheres to determine the joint lines for our patterns. That's the only reason we use the common central sphere. We use a sphere that everything is common back to that point. So that's why we use that. So anyway, look, I'll leave the drawing there. I've rambled a bit during this one. Hopefully it makes sense, and we will go from there. Thank you.